Carbon has 4 valence electrons, and that means it almost always forms 4 bonds. And these can be a combination of single, double, or triple bonds. If only carbon and hydrogen atoms are involved in the bonding, the molecules are known as hydrocarbons. There are 3 different classes of hydrocarbon. They are alkanes, alkenes, and alkynes. Alkanes have only single bonds, and all of the carbons are sp3 hybridized. With all of the central atoms being sp3 hybridized, alkanes have all bond angles very near to 109.5 degrees. Alkenes have at least one carbon-carbon double bond. The other bonds will be single bonds. As a reminder, anything with 3 domains, like one of these double-bonded carbons, is going to be sp2 hybridized and have bond angles of approximately 120 degrees. And again, any of the single-bonded carbons are going to be sp3 hybridized. And because of this, the shape of alkenes is going to be planar around the double bonds, and it's going to be 3-dimensional around any of the single-bonded carbons. Alkynes have at least one carbon-carbon triple bond. And because triple bonded carbons have a linear geometry, they're going to be sp hybridized. Up until now, all of the molecules that I've drawn have been what are known as straight chain hydrocarbons, where all of the carbon atoms have been directly connected to one another. You can also have branching structures, where there is a straight chain of carbon atoms, and there are carbon atoms coming off of that chain. So the longest chain of carbon atoms in one of these branch structures is known as the backbone or the skeleton, and then shorter chains of carbon will branch off of that backbone. What I've shown here is a 5 carbon long chain, which is going to be the backbone of the molecule. And now I'm going to draw a shorter branching chain. It can be tricky to identify the longest chain. You have to count all of the carbons to make sure that you've correctly identified the longest chain. This is one possible longest chain, and you count the carbons and there are 4 of them. This is another possibility for the longest chain. It too contains 4 carbon atoms. The final possibility for the longest chain contains 5 carbon atoms, and that's how you know that this is the backbone. Once you have the backbone and the side chains drawn, you can simply add hydrogens until all of the carbons is going to have 4 bonds. Sometimes organic molecules can be modified versions of a standard hydrocarbon, and they'll have groups of atoms attached to that organic molecule that change the overall reactivity of the molecule. And these groups of atoms are known as functional groups. And there are lots of different types of functional groups, and we'll talk about them in much more detail later. But for now, I'll give you an example of 2 different types, alcohols and alkyl halides. Alcohols are molecules that have an OH group attached to the carbon chain. This molecule looks like a 3 carbon long alkane, but its reactivity is going to be very different from your standard 3-carbon long hydrocarbon because of that OH group. Alkyl halides are hydrocarbons that have a halogen group added onto them. So chlorine, fluorine, bromine, iodine, one of those.